Welcome back to Statistical Reasoning. We are in Chapter 7 of the Elementary Statistics textbook, and we're going to work with estimating parameters of both proportions and means and determining their sample size. So the first thing we need to do is define what a point estimate is. And so a point estimate deals with what we think the estimate of the proportion is for the population. So we use the symbol P with an arrow on the top, and it's said as P hat. So we think that the P hat, it's a single value used to estimate for the population proportion. Because everything we do in statistics is trying to tell us something about the population, since I don't have the time or the resources to talk to every single person. So in this example here with Facebook, the Gallup poll was taken in which 1,487 adults were surveyed, and 43% of them said they have a Facebook page. Based on that result, what would be the best point estimate of the proportion of all adults who have a Facebook page? So based on this data, we're trying to say, what do we think is happening with the population? Well, we think that our best point estimate of P hat would be 0.43. That's the best we can do based on our study. If they ask for it as a percentage, we would go ahead and say it's 43%. Otherwise, we write it as a decimal. Now we're going to use that information to help us find an interval. So instead of using a specific number and saying that's what it is, we're going to say instead we have this interval where we think that the true population proportion is going to fall. We use the abbreviation of CI to count as our confidence interval. Before we can do our interval, we have to think about what our confidence level is. And our confidence level is going to change depending on the situation. If we're talking about anything medically, we're going to have a higher confidence level because it's crucial to life that we get it right. If it's not something that's very important, we could go maybe as low as 80% if it's something trivial. Our confidence level is found by doing 1 minus alpha. Alpha is our significance level. So for instance, examples would be, I used already 95% confident. We could do an 80% confident. We could do a 99% confident. We can never be 100% confident because that means we're right all the time, and that's just not going to happen in life. Now with that, I have a little chart here. So if we are 90% confident in our interval, then our alpha level, it's going to be 1 minus 0.9, that's going to give us an alpha level of 0.10. If we have a 95% confident, it's 1 minus 0.95, so I have an alpha level of 0.05. 1 minus 0.99 gives me an alpha level of 0.01. Now this 0.01, that's what we're going to use for the medical area. Anytime we're dealing with medicines or people's lives are in detriment. So it could even be with something with an emergency service system. And then as the cruciality goes down, then our confidence level can also go down. When we report our findings, we have to be careful in the way that we say it. So I have just some interval here between 0.405 and 455. I don't know what it means. It doesn't matter. When you state what you're learning about, we state things like we are 95% confident that the interval from blah, blah, blah actually does contain the true value of the population proportion. We do not say things like there's a 95% chance that it will fall between there, or that 95% of the proportions will fall between there. We are 95% confident. And here's a visual talking about that. We also sometimes talk about critical values. They help us know where we fall. So a critical value is a number. Oops, let's get my pen working. On the borderline separating the sample statistics that are either high or low from those that are not significant. Now, significant, if you remember, is stuff that's much different than the mean. So on our chart here, this is the mean. And so the stuff in the yellow is considered not significant. Use an arrow. This is considered not significant. The items in the tails, those are considered significant. This one would be low, significantly low, and up here would be significantly high, which means they're just a certain amount different that makes them important or significant. Now, if we are looking for this critical value that is separating our non-significant from our significant amounts, we have to base it on what our confidence level is. And so what we're going to end up doing is we're going to use our charts. And I do have an example that I'm going to show here in a second. They're the flip outs that are in your book, or they can be the back of your book, whichever you would prefer. So the first thing we have to do is figure out our alpha level. And a moment ago we talked about that our alpha level was 1 minus our confidence level. So 1 minus 0.95 in this case gives us an alpha level of 0.05. Now, notice our alpha is right here, and our z-score of alpha over 2 is going to be, we're going to take the 0.05 and we're going to cut it in half, so we end up with 0.25. Now what this does is it breaks it down by the tail. So I'm going to draw a visual of what I'm talking about. So that's in the middle. If I break this apart into tails, I have a piece here and I have a piece here. Imagine that they're symmetric. What this is saying is that each tail has 2.5% of the data, because my 5% significance is in both tails. So I've split it so each tail has that. Now, to find this critical value that is separating my significant amount from my non-significant amount, either on the low side or on the high side, I have to use my z-score tables. Now let's think about it. This is 0.025, this is 0.025. The z-score tables, and I'll show you part of one here. So notice here on the z-score tables, the numbers that are in here are from your critical value or your z-score all the way down on the left-hand side. So all the blue is included here. So when I think about that in this case, all of the blue, so that's going to be from here all the way down is what's included on the chart. So if this piece is 0.025, then all the way down is going to be 0.975. Now I got that from doing 1 minus 0.025 must be the leftover, which is all the way down. This is the number, this 0.975, that I'm going to look for on my chart. So I'm going to go to my chart here, and I'm going to look for 0.975. 975. So 975 is right, looking here. Oops, pen keeps going off, sorry about that. Here's 975. So now that I've found it, I go, okay, what z-score is that? Well, if I look to the side, I see the 1.96, and I look up, I see the 0.06. So the z-score, or the critical value, which goes with that 0.975, is 1.96. So if I go back to this slide, the critical value, the one on the upper end, is 1.96. The one on the lower end is negative 1.96. The sign just changes depending on if it's on the higher end or the lower end. So the critical value for this, because I don't know which end it is on right now, is plus or minus 1.96. Now if you continue to look on that chart and you look down toward the bottom, they do have some of the most common critical values down there. On the very bottom right hand corner you can see that the 0.95 is 1.96, the 0.90, 1.645, and 0.99 is 2.575. So these are some of the most common critical values that are used. Okay, and here they are again in the different charts. So this is similar to the chart we just saw on the bottom of it. Now, margin of error. When we are figuring out a confidence interval, you have to think about margin of error. You can't know for sure that it's an exact number when you're estimating about a population. So you give yourself a little room for error. If you think about stuff you've seen on television, especially during political elections, they always say like the current standing is they have 47% of the vote, and then behind it they'll say like a plus or minus 3 or a plus or minus 5. That's their margin of error. They're giving themselves 3 percentage points, 5 percentage points error, so they know that it's between a range. And so that's what we're going to be working with. To figure out what that is, we have a formula. So our formula is E equals, this is our critical value, same thing we just worked with. Then we're going to multiply that by the square root of p hat times q hat divided by n. Now those are hats, they're not n's. This is my n. Okay, now what do those variables mean? So first let's think about what those variables mean. The population proportion is the p. That's what I'm trying to find out about. My sample proportion is what I know about. That's my p hat. How many are in my samples? That's n. My margin of error is capital E. My critical value symbol, remember, is Z alpha over 2. So those are the symbols that I'm using here in this formula, and that's what they represent. Now I'm going to take a moment to find my confidence interval, but I have to think about some requirements first. Things that need to happen. One, you have to make sure you have a simple random sample. If you don't, you shouldn't be doing a confidence interval or any kind of statistics, though we sometimes do. The other things you want to look at, if we're focused on a binomial distribution, you want to make sure that they are a fixed number of trials. In other words, I'm not doing it until something happens. I know I'm doing it 50 times, or I'm doing it 1,000 times. I'm doing it 542 times. I know exactly how many times I'm doing it. I need to make sure the trials are independent, that one trial is not affecting another trial. I need to make sure that there's only 2 outcomes. So you have Facebook, you don't have Facebook in the situation that we were talking about earlier. You voted for the candidate, you did not vote for the candidate, or you voted for a second candidate. The last thing that you need to make sure happens is you have at least 5 successes and at least 5 failures. If that is not true, then you need to find a different method. So to actually make the confidence interval itself, we're going to do p hat minus margin of error. That's going to give us the lower limit. And for the upper one, we're going to do p hat plus margin of error. So this is the higher end, and this is the low end. And we already know how to find margin of error. Sometimes you'll see it written out in this form. Sometimes you'll see it written out as p hat plus or minus the margin of error. And that's just they don't want to actually put these numbers together. They leave it so you know what the p hat was and you know how far off you're being. So in the instance I was talking about earlier, if it's 47% vote plus or minus 3%, that's what it could look like. Or if I was using those numbers up here, it would be 47 minus 3 and 47 plus 3. So I would get a confidence interval of 44 to 50%. So I know between that's how many people voted for that candidate. Okay, so let's try it. We had a Gallup poll of 1,487 adults. We had a best point estimate of p-hat of 43%, so here it's been written as a decimal. First, we're going to find the margin of error that corresponds to that 95%. Then we're going to find our confidence interval and write a statement about it. So these are the steps we're going to work through right now. So in that situation, does it fit our requirements? So 1, was it a simple random sample? Well, the Gallup poll seems to be an organization that does their best to do simple random samples, so we're going to go ahead and say yes, that it does. Okay, are the conditions of a binomial experiment satisfied? 1, is it a fixed number of trials? Well, yes, they did 1,487 trials, so it's fixed. Are they independent? Well, as far as we know, the one person's answer of if you have Facebook or not has nothing to do with the next person's answer. We don't know if they did anybody in the same household or not. So we have to go that, yes, they are independent. Are there only 2 categories? Well, you do have Facebook or you don't. So there are 2 categories. Do or you don't. And does the probability remain constant? So the probability of having Facebook is the same all the way through, so yes. Okay, last requirement. Is the number of successes and the number of failures both at least 5? Well, having Facebook in this case is considered a success, so we're going to go 0.43 times 1487, and that's going to give us 639. Well, that's definitely greater than 5, so we're good to go. Then for the failures, if 43% have Facebook, then 57% don't have Facebook. 0.57 times 1487, doesn't really matter what the number is, it's definitely going to be bigger than 5, but it is 848. So yes, they are both successful. They are both bigger than 5, so I have met my requirements. When you are working with a poll, don't be super critical. Make sure your confidence levels are provided. Make sure you know your sample size. But if it is a smaller sample size, don't not do it. Okay, so margin of error. So formula for margin of error was z alpha over 2, which is our critical value, times the square root of p hat times q hat divided by n. So we have a 95% confidence level, which we've already figured out is a 1.96 critical value. Our p hat we know is 0.43. Our q hat we talked about a little bit already when we worked up here with our failures. If 43% of them are successful, then that means 57% are not. So our q hat is going to be 0.57. Our n is how many were in the group, and there were 1,487 in the group. So we're going to go ahead and do that calculation, and when all is said and done, we get approximately 0.025, and I did round that. So that is going to be our margin of error. So we're done with that. Now I have to use that to find our actual confidence interval. So if you remember up above, we're going to do p hat minus the margin of error, and we're going to do p hat plus the margin of error. So the first p hat, or the p hat in this scenario, is 0.43. We're going to minus 0.025, and then we're going to go 0.43 plus 0.025. So 0.43 plus 0.025 is approximately 0.405, and 0.43 plus 0.025 is approximately 0.455. So this is our confidence interval. Now we have to go ahead and make a statement about that. So we would say we are 95% confident that the population proportion of those that have Facebook will fall between 0.405 and 0.455, or 40.5% and 45.5%. Now, as this question asks, based on these results, can we safely conclude that fewer than 50% of adults have Facebook pages? Well, if you look at this, 50% is higher than everything that's in this interval. So can we safely conclude that? Yes, we can, since everything in that interval is lower than 50%. Okay. So now we took our best point estimate, we took our margin of error and the information, we found a confidence interval. What happens if I have to work the other way? What if they give us a confidence interval and I need to break it apart? So things that we need to know. We can find the best point estimate if they give us the confidence interval by taking the upper limit, adding the lower limit, and dividing by 2, because the best point estimate is smack dab in the middle. Now we can find the margin of error by taking the upper limit, subtracting the lower limit, so we're seeing how far apart they are, and again we're going to divide by 2 because we're finding out how far apart they are. We're cutting that in half. That must be the distance between the lower limit and the best point estimate, which must be the margin of error. Okay, so let's try it. In this article, the high-dose nicotine patch therapy, we know that of the 71 subjects, 70% were abstinent from smoking at 8 weeks. They did a 95% confidence, which gave them a 58% to an 81% confidence interval. We're going to use that statement to find out what our p hat and our E are. So, with my pen, to find p hat, we said take our upper limit. Our upper limit was 81%, so I'm going to do that. I'm going to do it as a decimal. I'm going to add my lower limit of 58% or 0.58. I'm going to cut that in half, and I'm going to get a p hat of 0.695. So that's my best point estimate. To find my margin of error, I'm going to take my upper limit minus my lower limit and cut it in half. And when I do that, I get 0.115. So that's the margin of error that I'm allowing myself in this situation. Now sometimes what will happen is if you're getting to the point where you're needing to start running tests, you need to know how big of a sample size do we need in order to do that. So we have to be able to estimate our sample size. To estimate our sample size, we need some formulas. If we know our p hat, in the case of the Facebook, we knew our p hat, it was 43%. If we know it, to find our sample size, we're going to do our critical value. We're going to multiply that by our p hat and our q hat, and then we're going to divide it by our margin of error squared. Now this is if we know p hat. If we don't know p hat, we're going to have to change it up because I don't know this information in order to use it. So we still use our critical value. We still square it. We still use our e squared. But over time, people have figured out that a pretty close estimate for when you don't know your p hat is to use 0.25. And that they've done just by over time using different calculations and figuring out what's the best choice. So if you don't know your p hat, you'll use this one. If you know your p hat, you'll use this one. So let's see what the next scenario is. When the author was conducting research for this chapter, he could find no information about the percentage of adults who make online purchases. Yeah, that information is extremely important to online stores as well as brick and mortar stores. If the author were to conduct his own survey, how many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? Now, The author is choosing the margin of error. He could have chosen to do a 5 percentage points or a 1 percentage point. That is up to the person who's doing the study. Assuming that a recent poll showed that 80% of adults make online purchases, so in A we know the p-hat, and in B we don't, so we're going to have to do the difference formulas. So on A, we're doing a 95% confidence, so let's think of what we know. We know our Z, our critical value, our Z hat over 2, if it's 95%, that's 1.96. We know, what else do we know? We know our margin of error is 0.03. We change our percentage points to decimals. We know our p-hat. Our p-hat is 80% or 0.8. So therefore we know our q-hat, because 1 minus 0.8 is 0.2. Okay, so we have our parts, so we can put them into our formula. So our Z alpha over 2, our critical value, is 1.96. We're going to square that. We're going to then multiply that by p-hat and q-hat. Then we are going to divide by our margin of error squared. We're going to plug that all into our calculator, and it spits out a number of approximately 682.951. Now, if you read that, it's saying do 682 people, but then do a partial person. Well, you can't do a partial person. And you want to make sure you have enough information so you never round down. Doesn't matter how small this decimal is, you always go up to the next person. So we're saying we should do 683 subjects to make sure we are 95% with a margin of error of no more than 3%. Now, what if we don't know anything about previous information about those that order online? In that case, we're going to have to use the second formula. We still have a critical value, if I can get my pen to work, critical value of 95%, critical confidence, say that, okay, one more time. We have a confidence level of 95%, therefore we have a critical value of 1.96. There, I got it said. We still have our margin of error at no more than 3%. So this time we're going to use the second formula, which is still taking our critical value, still squaring it, still have our margin of error on the bottom squared, but this time I don't have a p-hat, so I'm going to substitute 0.25 to do a best point estimate. And so the best I can do is approximately 1067.11, which, remember how I said no matter how small this is, it needs to go up. So we would want to make sure we do 1068 subjects. Now when you're doing this, if you find yourself in a situation where you don't have the resources to do that many subjects, you then are going to have to change either your confidence level, which will change your critical value, or you're going to change your margin of error, which will change how many you can get. And you'll go up or down accordingly based on what you have information for. Okay, so that's the end of section 7.1. I will work on a video for 7.2 so I can help you out with that, and we'll just keep going. Have a good day.